There is a process happening in the bodies of most people reading this right now that they cannot feel, cannot see, and have almost certainly never been told to think about. It is not dramatic. It produces no obvious symptoms in its early stages. It does not announce itself. It simply runs, quietly, continuously, below the threshold of awareness, while slowly damaging blood vessel walls, disrupting insulin signaling, accelerating the accumulation of amyloid in the brain, and creating the biological conditions from which most of the serious diseases of modern life eventually emerge. It is called chronic low-grade inflammation, and it is the closest thing medicine has to a unified explanation for why the diseases that kill most people in the developed world, cardiovascular disease, type 2 diabetes, Alzheimer's disease, several cancers, and clinical depression, all tend to occur together, share common risk factors, and respond to the same lifestyle interventions. Understanding what it is, where it comes from, and what actually reduces it is not a minor health optimization. It is foundational. Because if you address chronic inflammation, you are addressing the upstream driver of most of the conditions that determine how long you live and how well you live while you are doing it. To understand chronic inflammation, you first need to understand what inflammation is supposed to do, because it is not the enemy. In its acute form, inflammation is one of the most important biological processes in the human body. When you cut your skin or inhale a pathogen or damage a muscle during exercise, the immune system mounts an inflammatory response. Blood vessels near the site dilate. Immune cells flood the area. Signaling molecules called cytokines coordinate the response. Damaged tissue is broken down. Pathogens are targeted. Repair begins. The hallmarks of acute inflammation, redness, swelling, heat, pain, are not problems to be suppressed. They are signs that the system is working. The inflammation is purposeful, localized, and time-limited. It resolves when the threat is addressed and the repair is complete. Chronic inflammation is something categorically different. It is not localized. It is systemic, distributed throughout the body. It is not time-limited. It persists. And it is not responding to a specific threat. It is a background state of immune activation that the body has settled into, often in response to inputs that signal ongoing low-level threat without providing anything specific for the immune system to resolve. The cytokines that drive chronic inflammation, particularly tumor necrosis factor alpha, interleukin-1 beta, and interleukin-6, are the same molecules produced during acute inflammatory responses. In the context of an acute response, they coordinate healing. In the context of persistent low-grade elevation across months and years, they damage the same tissues they are supposed to protect. The cardiovascular consequences of chronic inflammation are the best documented and the most immediately life-threatening. Atherosclerosis, the process by which arterial plaques form and progressively narrow blood vessels, is not primarily a problem of cholesterol accumulation. It is an inflammatory process. LDL cholesterol particles that enter the arterial wall are oxidized, and the immune system responds to oxidized LDL as a foreign invader. Macrophages, immune cells, engulf the oxidized LDL and become what pathologists call foam cells. These foam cells accumulate, die, and form the core of arterial plaques. The plaques are stabilized or destabilized by inflammation. When chronic inflammatory signaling is high, plaques become more vulnerable to rupture. A ruptured plaque is the proximate cause of most heart attacks and strokes. The event that kills the patient is not the plaque that formed over decades. It is the moment the plaque ruptures, and inflammation is the primary determinant of whether it does. This is why C-reactive protein, a blood marker of systemic inflammation, is a stronger predictor of cardiovascular events than LDL cholesterol in many studies. The JUPITER trial, which enrolled nearly 18,000 participants, found that people with elevated CRP but normal LDL cholesterol had significantly higher rates of cardiovascular events than those with low CRP. Treating the inflammation, in the JUPITER trial, with a statin that also has anti-inflammatory effects significantly reduced those events. Inflammation is not the whole story of cardiovascular disease, but it is a central mechanism, and it is one that most people have never had explained to them in these terms. The connection between chronic inflammation and type 2 diabetes runs through insulin signaling in a way that is direct and mechanistically specific. Inflammatory cytokines, particularly TNF-alpha, interfere with insulin receptor signaling at the cellular level. Specifically, TNF-alpha activates an enzyme called IKK-beta, which phosphorylates insulin receptor substrate proteins in a way that impairs their function. The cell receives insulin, but cannot respond normally to it. Insulin resistance develops not just from excess glucose and fat overload, but from chronic inflammatory interference with the molecular machinery of insulin signaling. This means that chronic inflammation and insulin resistance are not just correlated, they are mechanistically linked. Inflammation drives insulin resistance. Insulin resistance, through the resulting hyperinsulinemia and elevated blood glucose, drives further inflammation. The two processes are mutually reinforcing, which is part of why metabolic syndrome, the cluster of insulin resistance, central obesity, elevated triglycerides, and high blood pressure, tends to present as a package rather than as isolated findings. Adipose tissue, fat, is not metabolically inert. Particularly visceral fat, the fat stored around abdominal organs, is an active producer of inflammatory cytokines. As visceral fat increases, so does the baseline inflammatory load. This is one of the mechanisms through which excess body fat drives metabolic disease, not through mechanical loading, but through the pro-inflammatory signaling that fat tissue generates continuously. The brain is protected from many circulating molecules by the blood-brain barrier, but it is not protected from inflammation, and the consequences of chronic neuroinflammation are now understood to be central to several of the most significant neurological conditions associated with aging. Microglia, the immune cells of the brain, exist in a surveillance state, monitoring neural tissue for damage, pathogens, and cellular debris. In an acute injury or infection, microglia activate, clear the threat, and return to surveillance mode. Under conditions of chronic systemic inflammation, microglia shift toward a persistently activated state. They produce inflammatory cytokines within the brain itself. They become less efficient at clearing cellular debris, and the debris they fail to clear accumulates. In the context of Alzheimer's disease, this debris includes amyloid beta, the protein that aggregates into the plaques characteristic of the disease. Research has established that chronic neuroinflammation impairs the microglial clearance of amyloid beta, contributing to its accumulation. Whether neuroinflammation is a primary cause of Alzheimer's or primarily a consequence of amyloid accumulation is still debated. But the bidirectional relationship, inflammation impairing clearance, accumulated debris driving more inflammation, creates a cycle that appears to accelerate disease progression. The depression connection is particularly significant in terms of how many people it affects. The classical model of depression centered on serotonin deficiency. That model has been significantly revised. A substantial body of research now points to neuroinflammation as a primary driver in a significant subset of depressive illness. Elevated inflammatory markers, particularly IL-6 and CRP, are found in a substantial proportion of people with major depressive disorder. Administering inflammatory cytokines to healthy people produces depressive symptoms, low mood, anhedonia, fatigue, cognitive slowing, at rates significantly higher than placebo. And anti-inflammatory interventions in people with elevated baseline inflammation produce meaningful reductions in depressive symptoms. This does not mean all depression is inflammatory. It means that for a significant subset, perhaps 30 to 40% of people with major depression, based on current estimates, the primary driver is immune dysregulation rather than monoamine deficiency. And for these people, treatments targeting inflammation may be more effective than treatments targeting serotonin. Understanding where chronic inflammation comes from is essential for understanding how to address it. And the sources are largely consistent across the research literature. Ultra-processed food is the dietary input most consistently associated with elevated inflammatory markers. The mechanisms are multiple. Refined carbohydrates and added sugars drive glycemic variability and advance glycation end products, compounds formed when glucose reacts with proteins that directly activate inflammatory pathways. Industrial seed oils high in omega-6 fatty acids, present in most processed foods, shift the balance of eicosanoid signaling toward pro-inflammatory compounds. Emulsifiers and additives in processed food have been shown in research to disrupt the gut microbiome and increase intestinal permeability, allowing bacterial products to enter systemic circulation and activate immune responses. The gut microbiome is increasingly understood as a central regulator of systemic inflammation. A healthy, diverse microbiome produces short-chain fatty acids that reduce intestinal permeability, support immune tolerance, and suppress inflammatory signaling. A disrupted microbiome, from antibiotics, low dietary fiber, stress, or ultra-processed food, produces less of these anti-inflammatory metabolites and contributes to a baseline inflammatory state. Sleep deprivation is a potent driver of inflammation. A single night of poor sleep measurably elevates inflammatory markers, including IL-6 and TNF-alpha. Chronic sleep restriction maintains these markers at chronically elevated levels. The relationship is bidirectional. Inflammation disrupts sleep, and disrupted sleep drives inflammation, creating a cycle that is difficult to break without addressing both simultaneously. Chronic psychological stress activates the HPA axis and maintains cortisol at levels that, over time, produce cortisol resistance in immune cells. The cells stop responding normally to cortisol's anti-inflammatory signaling, and inflammatory tone rises. This is one of the mechanisms through which chronic stress contributes to the same disease outcomes as other inflammatory drivers. Physical inactivity removes the anti-inflammatory signaling that muscle contraction normally provides. As discussed earlier, myokines released during exercise, particularly muscle-derived IL-6, suppress TNF-alpha and other pro-inflammatory cytokines. A sedentary lifestyle removes this continuous anti-inflammatory input, allowing inflammatory tone to drift upward. Here's what the research supports in terms of actually reducing chronic inflammation. Omega-3 fatty acids, specifically EPA and DHA, found in fatty fish and fish oil supplements, are the most extensively studied dietary anti-inflammatory intervention. They work through multiple mechanisms, competing with omega-6 fatty acids for the enzymes that produce eicosanoids, shifting eicosanoid production toward less inflammatory compounds, and serving as precursors for specialized pro-resolving mediators, molecules that actively resolve inflammation rather than simply suppressing it. A meta-analysis of randomized controlled trials found that omega-3 supplementation significantly reduced CRP, IL-6, and TNF-alpha across diverse populations. The effective dose in most studies is approximately 2 to 4 grams of combined EPA and DHA per day, achievable through fatty fish 3 to 4 times per week or through a quality fish oil supplement. The source matters. Fish oil supplements vary significantly in quality and oxidation status, and oxidized fish oil may have pro-inflammatory rather than anti-inflammatory effects. Curcumin, the active compound in turmeric, has anti-inflammatory effects that operate through inhibition of NF-kappa B, the primary transcription factor that drives the expression of pro-inflammatory genes, including TNF-alpha, IL-1 beta, and IL-6. The challenge with curcumin is bioavailability. Standard turmeric is poorly absorbed. Formulations that combine curcumin with piperine from black pepper or that use phospholipid complexes or nanoparticle delivery show significantly better absorption and more consistent clinical effects. Studies using bioavailable curcumin formulations have shown significant reductions in CRP and other inflammatory markers in adults with elevated baseline inflammation. Exercise is arguably the most consistent anti-inflammatory intervention available. Every session of moderate aerobic or resistance exercise produces a temporary anti-inflammatory effect through myokine release. Over time, regular exercise reduces baseline inflammatory markers, partly through this mechanism and partly through its effects on body composition, sleep quality, and stress regulation. The anti-inflammatory effect of exercise is dose-dependent up to a point. Very high-volume training without adequate recovery can actually elevate inflammatory markers through excessive tissue damage. Sleep is not optional in this picture. The research on sleep extension in people who are chronically sleep-restricted consistently shows reductions in inflammatory markers as sleep improves. Addressing sleep quality through consistent sleep timing, darkness, temperature, and reduced evening light exposure is not a lifestyle preference. It is a direct anti-inflammatory intervention with documented effects on the same markers implicated in cardiovascular disease, metabolic disease, and neurodegeneration. Reducing ultra-processed food consumption, even without specific replacement foods, reduces inflammatory load by removing the primary dietary drivers of glycemic variability, omega-6 excess, microbiome disruption, and advanced glycation product accumulation. The substitution of whole foods for processed foods in dietary intervention studies consistently reduces CRP and other inflammatory markers within weeks, independent of total caloric intake. Here is the framing that makes all of this cohere. Chronic inflammation is not a disease. It is a biological state, a sustained low-level immune activation that creates the conditions from which disease emerges. It is upstream of cardiovascular disease, upstream of metabolic disease, upstream of neurodegeneration, upstream of a significant subset of depression. The inputs that drive it, ultra-processed food, sleep deprivation, physical inactivity, chronic stress, microbiome disruption, are the same inputs that modern life delivers at high volume to most people simultaneously. The result is a population-wide baseline inflammatory state that was not present at anything like the current scale in previous generations, and that is the primary biological mechanism behind the chronic disease burden that now dominates medicine. The interventions that reduce it, omega-3s, curcumin, exercise, sleep, dietary quality, microbiome support, are not exotic or expensive. They are accessible. They work through documented mechanisms, and they address the upstream driver rather than the downstream diseases. You do not have to wait for a diagnosis to address chronic inflammation. Hit the like button. Share it with someone who has been managing symptoms without understanding the underlying biology. And subscribe for more content like this. See you in the next one.